Hello guys, welcome to class 12 of Python programming. We'll discuss about tuples today. Let me write one tuple 10, 20, 30, 40. Suppose we print this way. Normal print statement you can write here and you can see what are all the elements. Remember, it has to start with this left parenthesis and it will end with another parenthesis. So here when we talk about tuples, it's immutable. Very, very important. Tuples are immutable, but these are sequences. However, tuples are sequences. Sequences, when I say all sequence operations are available, we'll do some of them today. Tuples are immutable. However, they are sequences. The other sequences are list and strings as well. Set is not a sequence. We'll discuss more about sets in the next class. Now, before proceeding further, let's check directory. How many methods are available here? A we named here. We can check by A or directly we can write tuple. So let me write directory of A. It's a tuple. Check what are the methods available. We need not to worry about the special methods. So here we have only two methods, count and index. Only two methods available for tuple. We don't have append. Remember in list we had append method, append, extend, pop, all those methods are available. But here there are only two methods. You can count. If I write B like this is a tuple. Suppose how I can apply B dot. I want to count the number of times 20 appears here, or number of times 30 appears here, 40 appears here. Those things I can count here. So count method, whatever element you want, suppose 20, I want to count how many times 20 is repeated here. You see 3, 1, 2, 3. Then I can apply the other method, count the index, because 20 repeated so many times, it will show you the first time. This is 0 index, this is the first index. It's a sequence. Okay. So you will have indices also. 0, 1, 2, 3, 4, 5, 6, that way. From right hand side, it's -1. Remember? Indexing 0, 1, 2, 3, 4, 5, 6, 7, that way. If you want to count how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 8. If you want to print this one, you see 0, 1, 2, 3, 4. You can use this index. If you want to print from right hand side, this 8 is same as -1. You can write -1 here. So if you want to print this element, either you can write 8 or -1. Okay. So I can write here print, the name is B here. Then you write 8. -1, 40. Okay. Then you write -2, here -2, and from this side, from left to right, it's 7. So you can write 7 here. You get this 20. So you can get this by picking this one here, the index of this, and you print it. So you can print all 0, 1, 2. You print 4, 10, 20, 30, 40, 30, 20. See, 10, 20, 30, 20. I have to delete all this. Suppose you want to print all the elements and it's a long one. There are many elements here. Then you can write a for loop instead. For I in range 9 elements, right? You write 8 here, 0 to 7, 8 elements, I suppose. 1, 2, 3, 4, 5, 6, 7, and 9. Okay. 0 to 9, print A I. That means you are printing A0, A1, this is A2, A3, A4, A5, A6, A7, A8, right? Yeah, this is one way. See, one way of printing this tuple out of range. Again, you count. Okay. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. Index error. Okay. 10, 20, 30, 40. Oh, I've taken A here. 4 elements are present. I have to change it to B. No problem. So I replace it by B now. This is not A. Yeah. So run it. Okay. Range expected 1 arguments got 0. Here 9. So all that I printed 10 to 40. Remember one thing, it's very important when we print, we are getting in columns, right? I mean, in every row, one, in one column. So in one row, only one, in one row, only one. However, if you print here, then you see I got this way. The difference between this and this is here, how many print statements we have. Remember, when we write a for loop, it loops how many times? 8 times. Every time it prints b of I for some I. So what happens if you count the number of elements, number of print statements here? These are the number of print statements, okay? 9 print statements we have. Here we have only one print statement. We are printing taking the name. Here we are printing element by element and once at a time. In spite of that also you might ask me why we are getting in a row, why we are getting this way. Because when you run a print statement, Not only it prints a value, this is a very important concept. Not only it prints a value, it reserves the whole line here. See, it reserves the whole line here. So when this print statement will be executed with some I, suppose 0, it will not only print B0, it will also, along with that, it will print this one, then it will reserve this line. When I is looping, right, when the next value of I will be taken 1, when it will print B1, this space is no more available, because after printing it leaves the whole space, so it goes to the next line automatically by default. There is a way out. If you want to write in a line, here there is only one print statement. If you want to print any other thing here, suppose print star, or maybe and whatever you want to write, see star, where star comes next line, because after this print statement, whenever you write another print statement, that will go to the next line, because you have so many print statements here, that's why you are getting here. So remember, you are able to run this for loop. There are two types of for loops. I must have discussed in other classes. However, remember, here in this type, we are printing, taking their index like 0th, 1, second, third, fourth, fifth, that way. This is one type. I'll go to the other type. Okay, because this is a sequence, you can do this way. Now, how can you print all in one line in for loop? Even if you are using a for loop, how can you print all in one line? That's possible. You end each print statement with something else, suppose star only. So what will happen? Will not reserve the whole space here. So what we are doing is, suppose these are the chairs, 100 chairs, they are there in each row. Someone comes, one student enters and sits in one chair, the first one. Then he says, no, nobody can sit here in 99 chairs. These will remain vacant. That way, the next student, whenever he comes, he occupies this one, then this one, that way. Okay. So what we are saying here is, no, you end it with only one gap, whatever gap, it's star maybe. So see what will happen. Here, no, we have to end. Okay, let me write end. This is the syntax. See, now you sit here, you keep one place vacant, okay? Because here CK, we are within CK, Corona call. So we have to keep distancing. So you can keep one, you can leave one chair. You sit here, let the other guy sits here. That way you can do. Even if you don't want to write anything, you can write this also. Now you are able to match this one. This is one type of for loop. There is another type of for loop that also we can use here for I in range. No, we will not use range function. For I in B, whatever is there in B. In B, you can write any iterable. Remember, if you ask me, how can we know whether we can write this thing for a list, set, dictionary or not? You can use for all iterables. This is the syntax. Okay. The syntax is, if you don't know what is an iterable, please go through my other classes. Any iterable you can write. And remember, this is iterable. I can write here. These are iterables. So because this is an iterable, I in B you can write. Whatever is there in B, print that. It's so simple, right? Whatever is there, you print that. Here for I in B, you print B when I write. Every time it's printing B. I have to write I. Even here also, if you want to write in a line, you can do that. That's not a that's also possible. So there are two ways you can write for loop this way, this way. This is both are available for lists and tuples, even for strings also. But this way is not available for a set. You'll see we'll have a class on sets, probably the next class. You can watch how sets are used and how they are different from these data types, lists and tuple. Now, tuple supports slicing also. Suppose I write a tuple 10, 20, 30, 40. Normally, I'm saying tuples are used for heterogeneous data, whereas uh, lists are used for homogeneous data. However, if you want, you can use heterogeneous also in lists. In tuple anyway you can write. In both cases you can write. It's not a problem. But remember, if you want to write something else, uh, you have to mention it. Like suppose you want to write a list here, you have to write in list form. Let me write this way. But one exception, sets are not allowed. This is also there. This is immutable. Immutable means what? Print C means C will be printed. Print C not means first will be printed. That you know. Now let's try to change one. Whether we can change it or not. We can do that using a assignment statement. Suppose I will write C0 101 and I will try to run it. 101, you see the error, what error it's giving. Tuple object doesn't support item assignment. So item assignment is not allowed. That means you can't erase here and write 101. If you have written this way already, you have no options but to keep it. See, when I write 10, 20, 30, 40, 50, 10, 20, 30, 40, 50, that is fixed. You can't erase this one and write 101 here. If you need 101 anyway, you write another tuple, you make another tuple, you construct specially once again. So you write here and then run it. So you have both 10, 20, 30, 40, 50, 101, 20, 30, 40, 50. You can never change this one by an assignment statement. You can't change this one. It's immutable. See, I mentioned here, tuples are immutable. You can't write here. However, what you can do here is, suppose you have a list here within tuple, this one, and you make it this way. So you have a tuple within another tuple, and you have a list within a tuple. Yeah, fine working. If you want to check their length, suppose I write len, that is one operation. If you check length, okay, I have to write print because there are more than one. You can print more than one. If there are two, you have to write print statements. So you see, we have four here: one, two, three, four. Suppose these are not two. This is only one, one element of C. If you want to print 40, you can print, but if you print, suppose I print C3 here, you will get this tuple. Okay. See, this is the fourth element. The index is 0 for this, 1 for this, 2 for this, 3 for this. So I got this one. However, if you want to print the first one, you have to write 3, then 0, 40 here. If you write 3, 1, again you can write 0, 1, 50 here. Okay. So this is 0, this is 1 for this tuple. So the fourth element, the index is 3 of this tuple is another tuple. Remember. Now we try to change. We want to change it, okay? We want to change this one. You write C3 here, then we have 0 here. Suppose I write 101. It's not allowed because 0, 1, 2, 3, then 0, this one. It's not allowed because again immutable. But you make it a set, sorry, make it a list here. There was some other problem maybe. 0, 1, 2, 3, 3, 0, right? Okay. Can't assign to function call, it says line 3. Zero, 1, 2, 3, 3, then 0, that's fine. We write this way. Can't assign to function call. Okay. Okay, try with this. The problem happened because here integer object doesn't support item assignment once again. This is not 20. This one is 2. Yeah. Now you print C. See here we got 101. But we wanted different one. We wanted this one to correct. This 40. Let's make this 40 400. Okay. Or 4000. Now print C. See here 10, 20, 30. They are same. We are able to change this one because this is a list and list is mutable. That means you can change it. However, if this is a tuple, you can change it. Try with this. Can we do it? Tuple object doesn't support item assignment. Even if the whole is a list, there is a tuple which you want to change. So tuple is immutable. You can do that. Okay. Even if this is a list, you can do that. Remember. So control Z, make it a list. Yeah. Then do it. This is fine. Now come to this one. The whole is a tuple. It's immutable. You can change this. You can change this. You can change this. You can change this. However, list is mutable. That is within a tuple. Try with this D30. Make it 0. This 50 I want to make 0. Okay. So print D here. Integer object. Okay. You count here. How many? Yeah. 0, 1, 2, 3, 4. Right. Yeah, it's possible. In a tuple also, if you have a list within a tuple, there you want to make a change, you can do it. That's fine, no problem. Let's proceed further now. I have another tuple. 10, 20, 30, 40, 50, 60. Now let me run this. Yeah, this is fine. Now if I write E and I write this and I want to run this. See, all I got 10 to 60 here. Then suppose you want to get only up to this or up to this. You want a subset. You want to up to this. You want to get up to this. Okay. Suppose I write a number 4 here. Starting I have not mentioned means it will start from this one, the first one, 0th index. You run it. See up to this. Next you erase this one. You start from some point like 2 or 3 or 4 whatever, but don't keep any number here means it will go up to 60 starting from here. You run it. Okay. See, the last is not mentioned. If you want to mention the last, you can mention. Anyway, it's 60. That's fine. You write 5. See, we got 2, 40 and 50. So that way you can make a part of a tuple. So this is true in lists. This is true for tuples as well. Even I can write a tuple this way. I will not write anything. This is also a tuple. You can print E and print here. You have to write this bracket. But yeah, it's always good to write parentheses. Don't keep it open. Sometimes it creates problems. Suppose you write G is equal to only one element 10. Then if you don't write a parenthesis, then how can you know it's an integer, it's a number or tuple? Suppose I run it, that's fine. So now it's a tuple, because in tuple also, even if you don't write, that's an optional thing, though we write all most of the time, almost all every time. You have to write it. Even if you write it also, type of G, integer, it's showing integer. Okay, so you have to write a comma. Remember, if there is only one element, you have a single element in a tuple, you have to write a comma. It's a tuple. Even here also, you can leave it. You have to construct a tuple this way. You write a comma, then print. Let me write this. Yeah, this is a tuple. Fine. Now, let me write these symbols. Okay, A, B, C, and D. The problem is, I want a list here, you get empty list, that's fine. I want a tuple here, empty, that's fine. I want a set here, and I want a dictionary. Though we'll discuss these things in the next classes, but then set means basically it's something where repetition is not allowed. Suppose you check the length here, you will get 4, not 5, because 10 is repeated. And there is no ordering. You can't apply this for loop in sets. We'll do more later. You can't apply this way because there is no subscript, there is no indexing in sets. That is the difference. And in dictionary, that also we'll do later. I'm not going to that. But dictionary also, suppose I have a dictionary this way, then 2 maps to, suppose, B here. This is a dictionary. Okay, I can run. Everything is working. So this is one empty list. This is empty tuple. And you can make it empty also, not a problem. You can make it empty also. You run it. Everything is working. But check the type of D or C. Print type of C or D. They are same, right? It's a dictionary. That means for sets you can't write this way, because curly brackets we use both in sets and dictionaries. So what will happen is, if you write curly bracket, you will get a dictionary. So you can't make an empty set. So then how can you make a set? So yeah, there is another notation. We have to write set here. We'll go to that later. in the next class. But remember, you can have a empty tuple also this way. This is empty tuple. There is nothing. You just run it and check. Yeah, type of B you can write. You write B here. Tuple. It's a tuple, right? Now this is empty. If you have a empty list instead, then you can write append method and you can go on appending one by one element and you can get, you print B. Now B 10, then append another one, 20. So from empty list, you go on appending one by one element, 10, 20, 30, 40, 50. Then you can have a list, whatever you want. You can start with empty list, then you can go on adding one by one element. But that's not possible in case of tuple. Why? Why in tuple it's not possible? You check you have append method or not. I showed you when I started. I can show once again also if it's there. See, we have only two methods here, count and index. We don't have append method in tuple. So you can do this way. You can have an empty tuple. If you have an empty tuple, just keep it. That's all. You can do more of that. Now suppose you have 10, 20 and you have 30, 40. Then I want to add this to tuple. Then what will happen? You see, if it will be like a list or it's different. Check it. I'm giving some time. What we wanted, what we got. We wanted element wise addition. That is not possible. 10 plus 30, you will not get it here. 20 plus 40 will not get it here. Here addition means concatenation. That too this way. The elements are here already and these elements will be added here. Added means not the way we know. It's not integer addition. So they will be side to these elements. Now come back to this one. Multiply by 5 means you have to repeat 5 times. 10, 20, 10, 20, 10, 20, 10, 20, 10, 20. That way you have to repeat 5 times. Then you can find max, mean, sum, all this. Suppose we want to find here print 20 is the maximum, 10 is the minimum, and 30 is the sum of these two. These things also we can find. Let me write this. Delete this one as well. Suppose we have a tuple and we want to change one, say this one. We can do it. So if you make it a list of t. Now see, you can print L. It's a list. Now change the first element L0 to 101. So now print L. Now see LED change. Okay. So then what you can do is you write L2 tuple. We start with T. Now TT is the new tuple, or I can say new tuple NT. This was the original tuple. We got the list here. Tuple list L. Then print NT new tuple. See, we got 101 here. So what you can do is you apply list here to tuple, and you change it to a tuple from, sorry, you change it to list. From tuple you get a list. So the process is this way: from tuple you get a list 10, 20, 30, 40. Then change this one to 101. Then again change it to a tuple. That is the only way. Directly you can change it. Even you can't delete one here. You can't add one here. You can delete one here. There is no append method you can't add. You can delete one also. There is no way. There is no del method or remove or pop. There is no such method like list here. If you want, you can delete T totally. Print T now. See, T is not present. Okay. So T is not available. Not this way. I will write A is tuple 1020, then print A, and then you delete means you erase this, then write print A, still 1020. Erasing is not same as deleting. Delete means you have to delete it from the global scope. Okay. You check directory here. What name we gave before? A. See, A is still present. So this is not deleting. If you want to delete a variable, you have to use del. This is a function, okay, built in. So now if you check directory, A is no more available. See, A is not available. So you have to write delete here. Delete A. That way you can delete the whole tuple. You can delete one element. The last one is you clear it first of all, and then do a new one. You try to run this one. I don't remember whether I discussed this function or not. Enumerate. So normally in for loops, we write I here for I in A, we write, okay, for I in A, print I. Now I've written another J here and I use enumerate here. So then what will happen? You will get the index value and this one as well. The value and the index both. You make it a list and try. It's fine. You make it a string and try. Yeah, you have AMIT. Now you make it a set and try. Many claim that set is also a sequence. But how set is a sequence? You got the value 0, 10, and 160, 230. So you see at 0 you got 10, but 1 you didn't get 30 here. That's the problem. At 1 you should get 30 because it's a set. There is no such ordering. Ordering is not there. Even if I repeat it here, though I'll discuss set next time, see here now what will happen. I continuously write 30. So you will not get, okay, whatever way you are getting in list and tuple, you will not get in a set, though I'll discuss set next time. But yeah, remember uh, tuple strings and list, they are sequences. Set is a different structure, data structure. We'll discuss about sets and dictionary in the next two classes. Here, before completing, let me tell you that tuples are faster than lists. Uh, that's why the performance, definitely in terms of performance, it's better than lists. And whenever if you want to make it mutable, you don't want others to change it, you can make it a tuple. You can do every work in list and you change it to a tuple. Your method TUPL you can write and then you can keep it. That's all for tuples. Class is over. Thank you.